spent the first half of the semester looking at, say, a function that told us where something was, and then we took the derivative of that, and it would tell us how fast the thing was moving. So we were going from position to distance, from position to velocity. We're going to be reversing that. We're going to be going from information about velocity to information about position or distance traveled. So here we've got a table. We've got some rates in feet per second and some time in seconds, kind of like a snapshot. Every 5 seconds, we take a speedometer reading on whatever this thing is. So at the beginning, it was going 8 feet per second. After 5 seconds, at that moment in time, it was going 12 feet per second. At this moment in time, it was going to 13, etc. And our job is to figure out how far did this thing travel during those 20 seconds. It's really easy to do. All we got to do is multiply rate times time. Rate times time. That gives us distance. Over this period of 5 seconds, from 0 to 5, we don't know how fast it was going the entire time, but we know how fast it was going at the beginning, how fast it was going at the end. I think the best way to go about doing this is to average those together. Say if it started at 8 and ended at 12, it's a reasonably safe bet, not really safe, but reasonably safe to assume it was averaging something around 10 feet per second during that time. So we've got 5 seconds times an average rate of 10, which obviously came from the 8 and the 12. So I'm going to say that during the first 5 seconds there, it likely traveled around 50 feet. During the second 5 seconds, between 5 and 10, was probably going around 12 and a half. So I'd multiply 12 and a half times the 5 second duration there, and that comes to what? 62.5, I believe. During the third 5 second period, it was probably going somewhere around 11 and a half. If we multiply 11.5 times the 5 seconds, we're going to get 57.5. I did not do these ahead of time, and I don't want to waste your time punching them in the calculator. So please forgive me if I did make a miscalculation here. During the fourth period of 5 seconds, probably somewhere around 11 was the average, and 5 times 11 is, of course, 55. So if we add all these up, we get 55 plus 50 is 105, 167.5, 225. Again, I'm not going to plug that in the calculator, so I may have made a mistake there, but I don't care. So we know that, or we think, we can estimate that during this 20-second period of time, whatever this is traveled about 225 feet, which makes sense. If we look at this, these would average together to be somewhere around 12 feet per second. Over a period of 20 seconds would be somewhere in the 200 range. So I think that works out all right. Let's look at this one here. This will show us almost the same thing, but there's something we need to pay attention to here. This time we've got rate in miles per hour, so speedometer reading off a car for a period of 1 hour, around 60 minutes. But our time is in minutes here. So here we had, in the first one, we had a rate in feet per second and our time was in seconds. So all we had to do was multiply. We're going to have to do a little bit of adjusting here. Over the first 10-minute period, maybe we averaged around 15. So we'd multiply 15 times our 10 minutes. But again, that's in minutes, not in hours, and this is in miles per hour. So we're really going to have to divide that by 60, because that says that right now would be how far we'd travel if we did 15 miles an hour for 10 hours. Since the 60 minutes an hour, we're going to want to divide that whole thing by 60 in the end. So just multiply it by 1/60 in the beginning. Halfway between 30 and 40 is 35. So 35 times that second 10 minutes. 35 again times that duration of 10 minutes. Halfway between 30 and 25 is 27.5 times 10 again for that 10 minutes. Between 30 and 25 would be 30 times that 10. And then halfway between 20 and 35 would be 27.5 times 10. Now you probably notice this isn't a big jump here, but we have a 10 in all of these. So really we could factor that out and get 10 over 60, which would be 1/6. And you can think of that as each one of these things is 1/6 of an hour, right? 10 minutes is 1/6 of an hour. And then just add the 15 plus 35 plus 35 plus 27.5 plus 30 plus 27.5 again. And one of those is wrong. I just realized that. Maybe not. No, I think those are right. So whatever you get when you add those together and then multiply by 1/6 or divide by 6. And since we have an hour's worth of time here and our average speed appears to be somewhere in the 30 range, it's probably going to end up being somewhere around 30 miles. But I don't want to work that out. You can do that and be really confident in your answer. It's the ideas I want to make sure that you get, and I think that ought to do it for this one. Talk to you next time.